We are all welcome this morning. This is MTH212. As I said, we will be talking about the application of our metrics, especially how do we use row metrics in our work. We're talking about eigenvalue, eigenvector, eigenspace, and some other area. So at this point, when we are looking at it, then I'll be able to explain to us how do we use it in a critical moment. We use these eigenvalue and eigenvectors in application. As a mathematician, you need it. As engineers, you need it. As a technologist, you need it. As an information technologist, you need it. There's nobody in science that is, so far you're working in dynamical system, majority of us will resolve using eigenvalue to be able to know the stability of a particular problem. So once again, you are all welcome. I'll be sharing my screen. Like you said, there are typographical errors in some of those materials. I don't want you to, I want everybody to make sure you write so that it will help us. All these examples I'm going to give us, it will help us to be able to tackle any other questions. Then I will also give us classwork, so that I want us to use that moment of classwork to practice something to yourself. You don't need to copy anybody. You don't need to be looking for answers anywhere. Once you are in class and you know what we are doing, you follow it. Mathematics is very simple. It's all about you, not all about the work. It's all about you. Are you ready to learn? Are you ready to apply what the lecturer is talking about? I always tell us there's a difference between textbook and math and lecturer. Also, there's a difference between video and the lecturer. If you don't have idea, the video will not make sense to you. But if you have idea, the video will make more sense to you. So I want to help every one of us to do that this morning. So I'm trying to share my screen. Please, any question?
I have something to say.
Go ahead.
Some of us are, we have slow learners and fast learners. Somebody like me, I'm a slow learner because after all these classes and whatsoever, I will have to watch the video again, all over again, before I can easily understand, from the concept to the final this thing. So what I will have to say is that you have done so well by releasing the video to us. Somebody like me, I've been watching the video. Like this morning, I watched the last video and I understood it very, very well. So just bear with us. Even the classwork you are giving us, maybe you will just give us time so that we can, go through it and then work the classwork and then submit. Thank you very much.
Okay, it's well noted. Any other question, please, before we continue? Deborah, any question?
Sir, no question really, sir, but I don't know. I still want to emphasize on this MTH212 matter. It's getting out of hand, sir.
What is your lecturer doing about it?
No, the last time he said he would send mails to the necessary quarters, but we've not heard anything yet. Term 1 came like that and it went just like that. Term 2 and Term 3 the same thing. I sent a mail then to the response I got was they were correctly uploaded. I sent a screenshots of the questions that were wrong, but no messages till now. Even Term 2, Term 3 came out also. I sent the same mail, but I've not gotten any message. I've not gotten any response. Term 2 question, number 1 question for me was referring me to number 6, which I cannot access until I answer number 1. TMA3 also was from a different course material. Things like that.
Anyway, you see, maybe after the class, you can call me.
Okay,
Is
sir.
that okay?
Yes, sir. Thank you, sir.
Just call me on WhatsApp.
Yes, sir.
That's where you can
Okay.
reach me. Yeah. I know. We will see what we can do. Just call me on WhatsApp. But that line is only for WhatsApp message on WhatsApp. But don't be dismayed. Don't be disturbed. Do the little one you can do. That's my advice. Is that okay?
Yes, sir.
Okay.
Don't be disturbed at all. Leave the course that you know is giving you problem. Focus on the others. You cannot fail.
Amen.
Don't be disturbed. Is that okay?
Yes, sir.
So that's my advice for you. Because if you are disturbed now, it will affect other courses. And you'll be carrying the same thing all along. At the end of the day, you will discover that all the courses you fail all the courses. So please don't be disturbed. Any courses that is giving you problem, set it aside. Do your normal material they gave you to read it. Do you have the course material they gave you? Let's talk about it after the class, please. Is that okay?
Okay, sir.
Okay, let me share my screen. Can we all see my screen?
Yes, sir.
Yes, sir.
Can you see the platform? Or you are seeing the email? Which one are you seeing?
We are seeing the write-up, the mathematics.
Okay, so please don't let me remove you. If you know you are not, make sure you mute yourself. Except if I call your name, please. Thank you. Okay, as I said this morning, we'll be looking into eigenvalue. For our newcomer, you are welcome, because I can see new faces. For those of us that we know ourselves, you are also welcome. And for our latecomer too, they know themselves, they are also welcome.
Morning, sir.
You see, I did not call name now.
Good morning, sir.
Okay, the latecomer you can see them now.
Also, good morning, sir.
The chief. Okay, you are welcome.
Thank you, sir.
So eigenvalue, please kindly mute yourself. Eigenvalue and eigenvector. Let's look at the definition. The definition says, Muhammad, please stop typing on my screen. So let's talk about this. Let's A, capital A, which is our matrix. You can see the reason.
You are not recording, sir.
I think I'm recording. Let me stop sharing.
Sir, it's being recorded.
Don't worry. I will satisfy to both of you, whether it's being recorded or not. Let's check together.
Video is being recorded. It's recorded.
Is it recording or not?
It is.
Yes, it's recording.
It is recording. The recording is on.
It's on.
Yes, sir.
Yes.
Okay, thank you. Okay, can you see the screen again?
Yes, sir.
Yes, sir.
Okay,
Yes,
let
sir.
A which is capital A, B, let capital A be, we all know the meaning of capital A now. Thank God for those of us that have done our TMA. Although you said the stuff mark you wrong, but don't worry. Let capital A be an n by n matrix. N by n matrix. A scalar lambda, this is lambda. We call it lambda. It's a Greek word, lambda. This is D. A scalar lambda is called an eigenvalue of A. You can underline it, an eigenvalue of A. If there is a non-zero factor x bar, if there is a non-zero factor x bar, if there is a non-zero x bar, such that A, our matrix multiplied by x bar equals to lambda x bar. Please, all this definition matters. Such a factor x bar is called an eigenvector. An eigenvector of A corresponding to lambda. Corresponding to lambda. Remember, it's multiplied by lambda at A, and the factor we are talking about, we all know the factor. So is what we are dealing with. So please, let's take note of that. Okay, let's look at the example. Unfortunately, some of the examples in our course material are not well arranged. Maybe due to the network when they are uploading it, I don't know. Number one, let's look at this. Show that our x bar is equals to 2, 1. Is an eigenvector. Is an eigenvector of A, which is our matrix, 3, 3, 2, -2.
Sir, we can't see the board very well, sir.
Maybe it's your network. Can others see the board very well?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Please, is your network Try and locate a good place.
Okay, sir.
So if you cannot see very well, it's the network, not myself. I try as much as possible so that you guys can see. So corresponding to lambda equals to 4. Corresponding to lambda equals to 4. Now, in this case now, we know for you to solve this problem on eigenvector or eigenvalue, you need the formula. We know the formula now. Our formula solution will be, the formula is A matrix A x bar equals to lambda x bar. Ax bar equals to lambda x bar. So in this case now, we can proceed by saying that our A, we know our A to be what?
Matrix 3, 2, 3 minus 2.
The is what? 3,
3,
3,
3.
minus 2.
2 minus 2, right? Then what
Yes,
is
sir.
x bar? Our x bar is
2y.
2, 1 equals to, our lambda is what? 4.
4.
Multiply by 2, 1.
2, 1.
So how do we know? Remember the law says it's equal, right? Are you sure if you multiply what we have here, are they going to equal? Let's check. So it's going to be, we all know the multiplication is row multiplied by column. So it's going to be 3 multiplied by 2 plus 2 multiplied by 1. Then 3 multiplied by 2 again plus minus 2 multiplied by 1. So what do we have? Equals to
6.
4 multiplied by 2, then the same 4 multiplied by 1. So let's look at it. Let us look at it. Three multiplied by 2 is what? 6 plus 2. And here is 6 minus 2, which is same thing as 8, 4, right? So we have it to be 8, 4 here too. At the end of the day, we have it to be 8, 4. Please note, note that if lambda is an eigenvalue of A and x bar is an eigenvalue vector belonging to lambda, any non-zero multiple of x bar will be an eigenvector. I hope it's clear. That is, at the end of the day, if you have eigenvalue as our lambda, if lambda is an eigenvalue of A and x is an eigenvalue, is eigenvector belonging to the lambda, when you have any non-zero multiple of x bar will be our eigenvector. Don't worry, by the time we solve the example, you will know what we mean by eigenvalue and eigenvector. But I'm just showing us that at this point, now let's look at this. It's just like assuming that x multiplied by x bar equals to lambda x bar. So it simply means that if I introduce A multiplied by alpha x bar is the same thing as I can say alpha A x bar, which is the same thing as alpha lambda x bar. Remember that I can also say lambda is the same thing as alpha this. So what we are trying to show us here is arbitrary constant is our alpha that we bring in, that are used to open the bracket and see what at the end of the, remember the way we normally do linearly independent when we started, the same way that we introduced the arbitrary constants and we move on with that. So, but now let's look at the process. What are the process that we need to embark on? Steps. Let's look at the steps. Number one steps we need to know. Okay, the step I'm talking about here, they are to solve for eigenvalue. Okay, let me write it. I don't want to write before, but I need to, let me write this one so that we all steps to solve for the eigenvalues lambda subscript I and the corresponding eigenvector S bar I of an n by f matrix A. They can ask you in your exam, what are the steps of solving so. Sorry. Oh. Do the following. Let's look at this. Do the following steps. The first one, number one, is multiply n by n matrix multiply and n by n identity matrix by the scalar. Who can tell us what is a scalar? We are all science students. Subtract the identity subtract the identity matrix multiple from the matrix A. From the matrix A. From the matrix A. Number three, find the determinant of the matrix and the difference and different. 4. Solve.
Sorry.
Can you please mute yourself? Solve for the value of lambda that satisfy the equation determinant of A minus lambda I, where your I is equal and everything equals to 0. 0 bar. Then the last but not the least, 5, solve for the corresponding vector of each lambda. So these are the things we are going to embark on If you can follow these steps, you'll be able to solve any question related to this. Now, the question says, I've seen some of the questions in some of the past questions whereby they will ask you to calculate eigenvalue or eigenvector of a particular equation. Please, some of us on typographical error, I don't want you to shoot yourself at that point. Take your time and find it. The question says, find the eigenvalue and eigenvector of the matrix A, which is equals to, let's do by 2 by 2 first, then we move to 3 by 3. Now, when I have this question, what does it mean? Can you get it now? Somebody said it means some parts. It's not convenient for me to write on top of those things. Please. Thank you. Maybe when you watch the video, you can pause it. So the first thing you need to remember, like I said, the solution is here. Look at the step. The first step, can somebody read it for us? The first step, please.
Multiply n by n identity matrix by the scalar.
By the scalar what? Identity matrix, right?
Identity. Yes.
Now, you need to, what they mean by that, we have lambda, we have I. Remember the equation says, let me write it here. It says, we have determinant in bracket A minus lambda I. Everything equals to what? Equals to 0, right? Now, before you get to that point, you need to, I represent our I here. It simply means identity matrix. Who can define identity matrix for us, please? Someone. Should I call the name now?
Yes, sir.
Yes, go ahead.
That all non-diagonal entries to be 0. All the diagonal entries are 1.
Non-diagonal matrix. Diagonal matrix is what? It's just very simple. The diagonal matrix, they are all 1, while non-diagonal matrix, they are all 0. So what we mean by, look at this matrix. Your identity matrix will be the same thing as the matrix A. So for example, our I in this case is going to be 2 by 2 also. Which means if my I is 2 by 2, I'm going to have 1, 0, 0, 1. This is the definition we are talking about. This is I, because this is our diagonal matrix is this. Our diagonal entry is this. They are 1. Why others? They are 0. So take note of that. Nobody will give you in the question. They will only ask you to solve. Then don't say mathematics is wicked. Yes.
Sir, please, I want to know, is that the leading diagonal also?
Don't misquote us. Be careful. This is not row reduce, and we are not there yet. We are still on simple thing. We are just defining diagonal matrix. We are just defining identity matrix. Leading diagonal, you'll be talking about leading diagonal when you are doing row echelon and some other things. But this case, we are talking about identity matrix. I hope I'm clear. An identity matrix is whereby non-diagonal elements, they are all 0. While diagonal elements, they are all 1. Is that okay now? So let's continue.
Yeah.
So we can go ahead and solve for lambda I, meaning multiply it by lambda. It simply means lambda multiplied by 1, 0, 0, 1. We are just doing preamble. We have not solved it. Lambda multiplied by 1, lambda. Multiplied by 0, 0, 0, lambda. So you don't have any stress in there. So you have that one first. Then the formula, don't forget our formula says here. So what you need to do is just to move on. So let's move on by saying, at this point, A minus lambda I, we know our A to be what? Your A matrix A will be 7, 3, 3, minus 1, right? Minus lambda I, which is lambda 0, 0, lambda. Any question to this point? Silence means no question. Okay. So it simply means that this will minus this. Accordingly, this also will minus this. Have you seen it? 7, it will correspond to each entry. Not that you just say 7 minus 0. It doesn't work that way. So it's going to be 7 minus lambda. The next thing is 3 minus 0. The next thing is 3 minus 0. Then minus 1 minus lambda. So at the end of the day, we have 7 minus lambda, 3, and 3. Then we have minus 1 minus lambda. So these are the things you are going to work with. So that is step 2. Can someone read step 2 for us, please? Nobody? Okay, let's continue.
Subtract the identity matrix.
Okay.
Subtract from the matrix A high.
Subtract the identity matrix
matrix and multiply from the matrix A.
Okay, you can see what I did now. The identity matrix that we prepare from step 1 that will multiply with scalar, we are using it to subtract it. So that is what the step 2 is saying. Can you read step 3 for us, please?
Find the
determinant of the matrix of the difference.
Okay, now number 3 says we should find the determinant, that is determinant of the above 7 minus lambda, 3, 3, minus 1 minus lambda. We are asked to find the determinant. It is very simple. We all know the determinant. When you multiply this one by this, and you minus this one from it. So it's going to be, it's the same thing as determinant of 7 minus lambda, 3, 3, minus 1 minus lambda. So it's going to be 7 minus lambda multiplied by minus 1 minus lambda, then everything minus 3 times 3, which is 9. You remember now. So we're going to have, if you open the brackets, what are we going to have here? Minus 7 minus 7 lambda. So then we have plus lambda, then plus lambda squared, minus 9.
Equal to 0.
Everything equals to 0 because we are looking for the lambda. So at the end of the day, if you do your mathematics very well, you are going to have, we can rearrange this by saying, let's bring the square front according to the law, quadratic. You know, this is quadratic now. We have
minus 6 lambda.
We have minus 7 lambda plus lambda.
Minus
6 lambda. We have minus 7 minus 9.
Minus 16.
Minus 16. Everything equals to 0. Yes, Christina.
Sir, please, where is this 0 coming from?
Just to, we are looking for lambda. Remember when you are solving a quadratic equation, when you have minus b plus or minus square root of b squared minus 4ac, everything divided by 2a. Remember, at the end of the day, what we are using here, you have ax squared plus bs plus c, everything equals to 0. Right? You still remember that?
Yes, sir.
So it's coming from that angle, we are coming from that angle. Everything equals to 0 here. So we now equate, we also do the same thing that, okay, let our equation equals to 0 so that we can find the lambda. From here,
thank you, sir.
You understand now? From here, from here now, we can use this method or use factorization method. Yes, so it all depends. It's not a crime. If you know that you can't cope with factorization, please use this one. We will not give you what will not work for this method. So we will give you what will work. So if I want to solve it,
factorization.
If you use factorization method, okay, for example, step 4 says what? What is step 4 says?
Solve for the values of lambda.
Yes. So lambda squared minus 6 lambda minus 60 equals to 0. That's what step 4 says. I'm using factorization method. I know if I multiply, what would it give me? 16. Lambda is common, right?
Yes, sir.
Lambda, we have lambda squared. Aha.
Yes.
So I know something will give me 16 that will still give me minus 6, right?
Yes.
What can give me minus 6 is minus 8.
8 plus 2.
Plus 2 will give me minus 6.
Mm.
And if I multiply it, it will give me minus 16. So everything now equals to 0. Then let's treat them one by one to know. We can now say that lambda minus 8 equals to 0, or lambda plus 2 equals to 0. Then here lambda is equals to 8.
8.
Or lambda equals to -2. So this is what we call eigenvalue. Please write it down in your notes. This is what we call eigenvalue. The value of your lambda. So I believe it's simple. All you need to do is just to follow the steps. Now, how do we get the eigenvector? Remember the question says, calculate your eigenvalue and eigenvector. So our eigenvalue is here. Now let's move on to eigenvector. We go back to our original equation. We have number 5 now, step 5. For step 5 now, the original equation says what? 7 minus lambda (3). We have 3. We have -1 minus lambda. Now, what you do for us to get it, you have to take, this is where your work, the work is interesting, because you have to be careful. We pick the lambda, first lambda. We now try it when lambda equals to 8. What do we have in the matrix? Let's call this matrix B. Our matrix B will be what? 7 minus 8, 3, 3, -1 minus 8. So which is going to be -1, 3, 3, -9. So don't forget, I'm not going to be mentioning matrix A again. I'll be saying matrix B, matrix B, matrix B. Now, for matrix B, we are to solve matrix B by saying solve Bx bar equals to 0 bar. Bx bar equals to 0. That is the method. That's the formula for this. So for us to solve it, it's going to be interesting equation now. We are going to have our B to be, let's put our B there, -1, 3, 3, -9. Then what is X now? X bar will be, since it's 2 by 2, X1 and S2. Don't forget, equals to 0 and 0. Any question?
Yes, sir. So that 0 bar, what does it signify?
It's just it signifies the constant that we have initially. It's just a 0 vector that we need to create. For example, just to show us that this thing at the end of the day will equivalent to 0.
Okay, sir. Okay.
Let me just put it on a layman.
Any
question? Yes.
Yeah. Just as the way he was asking for that bar, can I be seeing that bar as a 0 vector?
That's what I'm saying. I said 0 vector.
Okay.
I said it. I said 0 vector.
Yes, sir.
So that is where anytime you see bar, you know we're talking about vector.
Okay. So the X bar is a vector too.
Yeah, that is what we are looking for.
Okay.
Yeah.
Is that okay?
Notice. Yes.
You remember when we had the last week we saw something similar. Do you remember? When we have 3 by 3 matrix, I was teaching you guys about reduced row echelon, RFE or RRFDE rather, is the same thing we are going to use now. At this point now, we are going to use using row reduction. Using row reduction method, we have for us to use row reduction method. Remember, when we are solving it, I told us last time, which of the method will bring the constant inside? Check your notes. We have -1, 3, 3, -9, and we have it this way, 0, 0. Which of the methods that normally do that? Anybody?
Gaussian elimination method, sir.
Gaussian elimination method.
Yeah.
Please. Is it Gaussian elimination method? Do we agree?
Yes, sir.
Do we all agree?
Yes, sir.
Row reduction.
That's very important for me.
Row reduction. Method.
Row reduction. Anyway, you have it in your notes or check the video. Now, for Gaussian elimination method, we know how do we reduce this? The first thing we need to do is what?
R2.
Let's check it. Can we quickly do that on our own? Everybody do it. Check the previous notes. Everybody do it. Everybody, please do it. Let's do it. We have 1 minute more. 1 minute. Is that all? You only have 2 operations to perform. 2 or 1. 1 operation is okay. Who can tell us the operation?
We make R2.
Yes, I know R2.
R2, 0.
What is the okay, R2?
R2
to what?
To R2 plus 3R1.
R2
R2 plus
3R1.
Plus 3R1.
Okay, do we all agree? Let's try it.
Yes, sir.
No, meaning that our R1 will remain -1.
Yes.
3.
Yes, sir. Yes.
0. So R2 will be 3 plus 3 times R1. 3 times 1 -1 -3 is 0. So we give us 0 here. Then the second phase, -9 plus 3 times 3, 9. 0.
0 again.
Do we all agree?
Yes, sir.
Okay, now we can proceed. Since we all agree, we can see the beauty of row reduction. That is why all these topics, you cannot escape them. We all know that this is X1 and this is S2. By the time you open the bracket, you will have it to be -X1 plus 3s2, everything equals to 0. Do we have anything in second row? Nothing,
No.
0. So we don't need it. So all we need to do is just to solve for x1 and s2. So you agree if I say that 3s2 is equals to s1. 3s2 is equals to x1. Who can tell us what to do at this point? As a scientist, what will you do?
Anyway, you see x1, and as in anyway, you see x2 multiplied by 3.
S2 multiply, where do you see the 3?
As in x2 multiplied by 3 should be equal to x1.
Yes, we've done that. So what do we do? How do we get S1 and S2?
How many values of x1 and x2?
We can't get your voice, ma.
There are many values of x1. So whatever x1 is, sorry, there are many values of x2. So whatever x2 is, tries of it to give us x1.
What is
get
S2?
If you get the value of x2, divide by 3, you should get x1.
And what is the value of S2? That's the question. Yes, anybody? I need mathematician in the house. As a scientist, you have to think. What do you think if you are the one?
I guess x1 will be 1, then x2 will be 3.
Oh, you know, you remember you are looking for x. The only thing you need for now, let me explain things for you. You and I know that 1 multiplied by anything will give us that value, right? I will assume let's S2 equals to 1. Let S2 equals to 1. Don't ask me, where do you get the 1? Because I know the next question will be that. Yes or no? I know that's your question. But that, let me explain. I'm just kidding. Remember, the only thing you can do here is just to divide. The only thing we can do at this point, if you divide both sides by 3, you will still have S2 equals to 3, S all over x1 over 3, right? So you are still complicating the issue. So the best thing is just to make S1, S2 to be equals to 1. Because you and I know that you can afford to hold 1. 1 multiplied by any value will still give you that value. I believe I'm making sense. So
Yes, sir.
Yes, sir.
Now we can now go ahead and say 3 into 1 equals to x1. Therefore, x1 is equals to 3. So we now have it in this way. This is what we call eigenvector. So you can see s1 equals to 3 and s2 equals to 1. Therefore, eigenvector our eigenvector will be 3, 1. You have to put it in matrix. So remember, we are working on matrix. So that is the first one. Now, you will also solve when x, remember when lambda equals to 8, that's what we solve. So I will now put it to you, everybody, can we quickly solve when lambda equals to -2? I believe it's simple now. When lambda equals -2. Okay, over to you guys. We have 3 minutes. Just 3 minutes. Your time starts now. Once you get your own, raise up your hand. I will call you. Don't type it, or don't give people orijo. Only 3 people raise up their hand here. So I'm still waiting for others. Still the 3, I'm waiting. Remain 1 minute to go. A minute to go, a minute to go. Okay. I hope it's not hard. Is it hard? Francis, what did you get?
Sir, I got x1 is -3, then x2 is 1.
Really? Okay. Tayo, what did you get?
Sir, I got x1 is equals to -1/3, while x2 is 1, sir.
Okay. Deborah, what did you get?
X1 is 1 and X2 is equal to -3.
S1 is 1.
1.
Then S2 is okay.
-3.
Sir,
Yes, somebody
Sir, the
else.
same with me
yeah,
too.
sir,
x2
me.
is 3. I'm so sorry. x2 is -3. Then x1 is 1. That is what I got.
Sir,
No problem.
sir,
Musa?
yeah, I got x1 is 1, x2
Okay.
is 5/3.
Okay, correct. We will check again. I believe we are all, we can continue now. Somebody is talking. Is it Joshua? Who call his own now?
I'm still on it.
Okay. Okay, let's look at it. Thank you. At least you make an attempt, but let's look at it together. We can call this one C. Let's say C equals to 7 minus 2 minus 2 will be plus, right? 3, 3 minus 1 plus 2.
That's 1.
So we have it. This is better you do it like that. If you just say that's 1, people will ask you, how do you get the 1? So to save that question, write it boldly for everybody. So don't forget, we have it. We have to proceed by saying we can say C x bar equals to the 0 bar, which is our factor. We have 9, 3, 3, 1, S1, S2 equals to 0, 0. So at the end of the day, using the row reduction, what do we have here? For row reduction, we have it to be 9, 3, 0. You have 3, 1, 0.
0.
So what is the operation here? Who can tell us the operation, please?
R2.
Deborah.
So R2 minus R2, as in R1 minus 3R2, that's what I did.
Okay, what again? Who else again?
Okay, we'll make the row in R2. Now say R2
R2
9 R2 minus R1.
Why?
Yeah, to make this one 0, to make the 3 0 there.
Why? Okay. Let me ask you. Why not R1? Why R2? Because you can as well interchange. Who is making noise there, please? Deborah. I know she's always in class. Okay, Ojo Titus.
Hello, sir.
Yes.
Yes, sir.
By fault.
So what is the operation you use?
R1 is R1 minus 3R2.
3R2. Okay. Musa, which one, what operation do you use?
The first one I just called R2 equals to 9R2 minus R1.
Okay. Titus.
Yes, R2 is equal to 3R2 minus R1.
R2 equals to 3R2 minus R1. Okay. Francis.
I use the same thing as Deborah, R1 minus 3R2.
Okay. That means you are together.
Yeah.
Okay, you are not copying each other. Correct.
No, I did mine separately, so I can send you screenshots.
Which screenshot again? When you are together now?
We are not together. I don't. She's not here with me.
Okay, let's continue. Now, I love this option. Please mute yourself. I love this option. But you have to be careful with a big value. Some of us using this one, you'll find it difficult to get it. You already have 3 in R2. If at all you want to use 9 to divide them, to multiply them, just say 3R2. It's not 9R2 again. I hope I'm communicating. If you want to make it 9, it's just to be 3 multiplied by 3, 9. And it will neutralize the first one.
Yes, sir.
You understand?
Yes, sir.
Now, but that's not the issue. The issue is R1. Forget about, you can solve it and interchange later. I told you in class. If I want to neutralize this now, I can go ahead and say, okay, based on Gaussian elimination method, I can still do it this way. I can retain my R2, 3, 1, 0. Why? Because it is simple for me. I can eliminate those ones. Look at it. If I said R1, R1 is 9 minus 3R2, which is also 9, equals to 0. I put 0 here. Then the second phase, I can say 3 minus 3, 0. I put 0 here. So, you know, you and I know that we can interchange and it will give you 3 whatever you want to. But besides, remember, we are just reducing this. We are not really going to Gaussian row reducing that leading element must be 1 or no. We are not going into that. So we are just trying to reduce it. So in this case, we know that S1 is there, S2 is there. Everything equals to 0. It's possible. We have 3 S1 plus S2 equals to 0. So I can say that let S2 equals to minus 3x1. So minus 3x1, I can now go ahead by saying, let my x1 equals to 1. If I put my x1 to be equals to 1, so it's going to be S2 equals to minus 3, then S1 equals to 1. How many of us got it?
So I got it.
Okay. So your eigenvector is going to be, yes, 1 minus 3. Somebody raise up your hand.
Yes, sir.
Go ahead.
What if we decided to make x2 to be equals to 1? Are we not going to arrive at the same thing?
You can try it if you said S2 equals to 1, but you might not get, remember, it is always advisable to make the one with, the one that has the coefficient, to make it to be 1. You understand? Look at the first one that we did. I used the one with coefficient 2. When we got there, I used the one with coefficients. So that by the time I'm open the bracket, I know I'm multiplying with something. Look at it. Do you have idea? You get the point. And don't forget, the load has already been reduced. So that is just it for another day. So I will just explain the last one and you guys will complete it in your own space, which is the 3 by 3 matrix. The 3 by 3 matrix is the same method we use, but the only challenge is how to get your lambda. But it is simple if you follow the simple arithmetic. Some of them leads to polynomial because of the, so let's just quickly look at this. Another example.
Excuse me.
Yes.
From the exercise we just did now.
Yes, sir.
We discovered that the first lambda is minus 2, and the other one was 8. And we substituted and got the eigenvectors.
No.
So now, I mean,
what
we substitute
did,
them individually.
Yes, you take them one by one.
One by one. And we now got the
another matrix.
Okay, another matrix. From the matrix, we now got a vector.
Exactly.
So now in exams, which one are we going to use? Maybe we are having 2 of 8. Am I using the 2 or the 8?
Now, it depends on what the lecturer asks you to do or the examiner asks you to do. The examiner can say, find the eigenvector when lambda is equals to 3, and they give you system of equation.
Okay.
So meaning that they already calculated the eigenvalue. You don't need to bother yourself.
Okay.
You understand? Just come to this place. The way I substituted it, you know that you are going to multiply your matrix they gave you in the question with lambda. It's going to be 9 minus lambda. You already have the lambda, right? For example, what I'm trying to say is this. I think I've seen questions like that. Let me just give you this. It's just an int. Now, for example, if you have let's say I said where lambda is equals to 3. They don't give you a system of equation. They have to find eigenvector. Find eigenvector when lambda equals to 3. They don't give you matrix A equals to 4, 2, 1, 7. So if you are the one, what will you do?
Okay.
Tell me now.
All right. If I'm the one presently now, it's if they have reduced a lot of work for me, I'll substitute the lambda into the equation first. That is 4 minus 3.
Yes.
Yeah. And then 7 minus 4.
No.
Yeah, it's 7 minus 3. Sorry, sir.
Exactly.
7 minus 3, all equal to 0.
Exactly. No, they are not equal to 0.
Vector. 0 vector.
Yeah, they are
0.
No, listen. If you are given this equation, or they just give you 4x1 plus 2x2 equals to 0. I hope I'm not giving you the secret. 1 plus 7 x equals to 2. They now said equals to 0. Now said find eigenvector.
This one is straightforward, sir.
It's straightforward because you have idea now. So what you do in this case is just to write. It's very simple. Yes. Write the matrix, call it A. We already call it A here, right?
Yes, sir.
So you and I know that I'll just do it this way by 7, 4 minus 3, 1. Nobody is interested. Remember, your own is MCQ. Just do it in your rough sheet of paper and do it. 2 and 7 minus 3. Someone that did not come to this class that will just be doing Baba Jebu. I will call this one B. I can call it matrix B that says, this is what now? 1, 2, 1, 4. So I'm going to have B x bar equals to 0 vector. That's all. Then I will do the row reduction to this one. Then I will get my, equate everything to be 0 and get my X and Y. That's all. I hope it's clear. Hello?
Yes,
sir.
Yes, sir. It's very clear.
Okay. So don't say they did not teach us that one. It's the same thing. It's the same thing. So for 3 by 3 matrix, I hope I can finish this. Then let A equals to 4, 6, 10. 4, 6, 10. Then we have 3, 10, 13. Then we have minus 2, minus 6, minus 8. So at the end of the day, they ask us to find eigenvalue and eigenvector. Find eigenvalue and eigenvector. Or they can also put it this way, that they can ask you, because it can be, they can ask you to find the root. They're still talking about, you can say that find eigenvalue, find eigenvalue lambda I, where your lambda I are roots of determinant A minus lambda I, which is equals to 0. So we know what it means. So let's quickly solve it before we call it a day.
Sir, are we solving the two questions or just one?
Don't worry, I will explain to you.
Okay, sir. Okay.
Remember that you need to create lambda I. You remember now?
Yes, sir.
For you to create lambda I, you and I know it's 3 by 3 questions.
Yes,
It's going to be
1
lambda.
lambda.
Don't say 1 again.
Okay,
0,
lambda,
0.
0, 0, 0.
0, lambda, 0.
0.
0, 0,
0, 0.
lambda. Do we agree?
Yes, sir.
So, okay, we can continue by saying we want to find the determinant. The determinant is, what is our A?
4 minus lambda.
4, 6, 10, then 3,
10, 13.
3, 10, 13, then
minus 2, minus 6,
minus
minus
2, minus 6, minus 8.
minus.
Everything minus lambda. Zero lambda, 0, 0, 0 lambda. We are finding the determinant of those two. So at the end of the day, they are going to equals to
4 minus lambda.
4 minus lambda, 6,
6,
10.
10.
3, 10 minus
10
lambda.
minus lambda.
Sorry.
13.
13. Then the last one,
minus
2, minus 6,
minus
8,
minus 8, minus 8, minus lambda.
Lambda. So the same way we do determinants will be the same way you will do this one. Remember, plus, minus, plus. So let's pick the first one, which is our 4 minus lambda, which is going to be 10 minus lambda. Do you agree? 13 minus 6 minus 8 minus lambda. Then you have minus 6. Do you agree?
Yes, sir.
You have 3, 13, minus 2, minus 8, minus lambda. Then plus 10. We have what? 3, 10 minus lambda, minus 2, minus 6. So we can solve it one by one so that you won't give yourself unnecessary headache. I can just pick the first one. 4 minus lambda. Open the big bracket. Okay, let me open this. I hope it is interesting, right? Okay. You can now open this bracket, multiply 10 minus lambda, multiply by minus 8 minus lambda. You agree with me?
Yes, sir.
Minus 13 into minus 6. That's all. So let's resolve this one before we pick another one. For your own good. Or we can just say that because of the space, minus 6, open the big bracket again, 3 into minus 8 minus lambda, minus 13 into minus 2. The third one, plus 10.
3,
6.
It will be 3 multiplied by minus 6 minus
10 minus lambda in bracket.
Is minus 2 again, right?
Yeah, minus 2.
10 minus lambda.
Minus.
Let's say plus 2, right?
Yes.
Yes.
10 minus lambda. That's all. So I'm not going to bother you, but I still need to open it because let me solve the first one. I will try and do that for you now so that some of you will not be, what is this man is saying? So the first one will be, you have 4 minus lambda. If you open the bracket, what do you have? Minus 80, right?
Yes, sir.
Minus 10 lambda plus 8 lambda,
8 lambda plus
lambda squared plus 78. Let me try and resolve this one. Let me try and resolve this one by saying, at the end of the day, I have.
Hello, sir.
Yes.
Please, can you bring down your screen a little bit?
So we have, in this case now, by the time you work on it very well, you have minus 2 lambda plus
lambda
squared. So at the end of the day, I have lambda cube minus lambda cube rather minus lambda cube plus 6 lambda squared minus 6 lambda minus 8. If you open it very well, so the next thing is to go back to the one with 6, minus 6. Minus 6 is going to be minus 24 minus 3 lambda plus 26. At the end of the day, you have this one to be minus 12 plus 18 lambda. Don't forget, we are still coming to them. Now, the last one will be, which is 10 minus 18 plus 20
Okay, I'm going to put the water.
which is going to be, at the end of the day, you are going to have 20 minus 20 lambda.
Are you who the one beside you up?
Musa?
Sir, I'm not the one.
You raise up your hand.
Okay,
Lower your hand, please.
Okay, sorry, sir. All right, thank you, sir.
You're welcome. Okay, so we can now add all the star together. Our determinant of A minus lambda I is the same thing, is star plus star star plus star star star. Yes.
Captain.
Any question? So it's going to be minus lambda cube plus 6 lambda squared minus 6 lambda
minus 8
minus 8 minus 12
plus 18 lambda
plus 18 lambda plus 20 minus 20 lambda. So if you solve it very well, this is what you are going to get. It's just a simple arithmetic. Lambda 3 minus 6 lambda squared minus 8 lambda equals to 0. Don't forget, if you solve it very well, you have this. So if you don't solve it very well, you have 0.
So is it that you multiply both sides by minus?
Sure.
Making the
you can multiply through by minus so that negative will not be on the highest power.
Okay.
So we have it to be, lambda is common to them. We have lambda squared minus 6 lambda minus 8, all equals to 0. Then lambda 1 will equals to 0, or lambda squared minus 6 lambda minus 8 equals to 0. So you can now go ahead and solve this one to get the remaining eigenvalue. So for us to get the remaining eigenvalue is simple. Minus b plus or minus square root b squared minus 4ac over 2a, where your a is equals to 1, b equals to minus 6, and c equals to minus 8. So we can go ahead and solve it. So if you substitute it very well, what do you have? Everybody, please do that.
Lambda is equals to 2 or 4.
Minus
Okay.
2 or plus 4.
Lambda
Minus 2 plus 4.
is it minus 2 or 2?
Minus 2
2, sir.
plus 4.
Where do you get
Lambda
minus 2, bro?
minus 2. In terms of factorization, I use factorization. I
Check
have,
it again.
okay, lambda plus 4. Open another bracket, lambda minus 2.
Will it
Then
give you?
finally, lambda will be 2. Yeah, it will give me.
Use general formula that I gave you. I don't want to be, it's going to be lambda 2 equals to what? 2 or lambda 3 equals to 4, right?
Yes, sir.
Guys, just check it by yourself.
Yes. Okay.
It's just a quadratic equation.
Yeah.
So at the end of the day, we have elements. You try to solve where you have V1, V2, V3. That is vector space 1, vector space 2, vector space 3. The first one will be, so the B aspect of it is aspect of the compute. The question can ask you like that, compute eigenvector. VI. That is, VI means V1. Remember, we have lambda 1, lambda 2, lambda 3. So VI is what we call non-space. Let me call it VI here. It's called non-space of A minus lambda I, capital I. Lambda subscript I, capital I. So it is the same thing we've been doing. Remember, we put I because our I start from 1, 2, 3. We have 3 lambdas now. So you can check it one after the other. When your lambda is equals to, what do you have when your lambda equals to 0? What do you have when lambda is equals to 2? And what do you have when lambda is equals to 4? So for, yes.
One of our lambda is minus 4, not 4.
How? Do you
Please
consider the negative 8?
Yes. Yes, sir.
Okay. What does it give you?
It will give us 1 is 2, the other one is minus 4.
Have you used the 2 method? Please use the 2 method and confirm with me. Let's solve for V1 first. For V1, remember our lambda 1 is equals to 0, which implies A minus lambda 1 I, which is the same thing as A minus 0 I, which is equals to A. That is, this is not a 0 vector now. This is normal 0 because our lambda 1 is equals to 0. So by the time you multiply lambda 1 equals to 0, what do you have? You have A. So we have to find non-space of A. For you to find non-space of A, we all know our A. Bring all your A down, and we'll bring all our A down to be 4, 6, 10, and 3, 10, 13. Remember, There is 0, 0, and -2, -6, -8, 0. Sir, have you confirmed it?
I'm trying to catch up with you again.
Okay, you can do that later, no problem. But I'm sure it's 4. Just try and check it.
Yes, sir.
So we have this. I believe to this point you are okay. We can do the row reduction in order to get our value. Our target is just to reduce the rows. So for us to reduce the row here, let's start with row 3, which will lead us to 2 row 3 plus row 1. 2 row 3 plus row 1. It will give us our row 1 will remain 6, 10, 0. So row 2 will also remain
3.
But for row 3, we have 2 multiplied by row 3 minus 4 plus row 1 plus 4 equals to 0. We put 0 here. So -6, which is -6 times 2.
-12.
-12 plus 6 is still -6, right?
Yes, sir.
Then -16
-16
plus 10 -6. 0 here. So how can we reduce further? Let's go to 1. What is 1? What happened to 1? I can say my R1 implies that 1 all over 4R1.
Okay.
So we have 1.
2.
This is 3 over 2, not 2. Right? Are we there?
Yes, sir.
Yes, sir.
Yes,
So
sir.
here we have what? 5 over 2. That is, I'm just saying 6 divided by 4, which is what? 3 over 2. And 10 divided by 4, which is 5 over 2. So that's what I did.
So why are we using 4? 4 will still maintain some fraction that will give us problem. Why
It
not
doesn't
2?
matter. Forget about whether fraction or not. Remember, we have to reduce the leading entry element.
Okay. Okay.
According to the Gaussian elimination, Gaussian rule.
What I'm saying, why not we leave this one after we are through, then we now reduce the leading element because
You
of
can
the
do,
fraction.
I've told you, there are many ways of solving it. Just pick the one that is convenient for you and solve. In this case now, it's still the same thing. But you just have to be consistent with what you are dealing with. So now we need to remember that we are almost done. We are still reducing the rules. Now let's work on 2. So what will happen to 2? I can say row 2 minus 3
row 1.
Row 1. I understand your plight. You are afraid of fraction.
Yes, I will.
That is it. But mind you, the more the value is getting bigger, the more you give yourself unnecessary headache too. So row 1 will remain the same at this point. So for row 2 now, we are going to have 3 minus 3, which is 0. Then 1 minus 3 in brackets 3 over 2. What is it, please? 11 over 2. Do you agree? Then the next one will be 13 minus 3 multiplied by 5 over 2.
So that row 2 is supposed to be 10.
Which of them?
The row 2 supposed to be 10 from the beginning.
Thank you. God bless you, ma. I'm doing it as 10, but I'm putting 1 there. Thank you. So this one will be what now? 11 over 2 again, 0. Then our 3 will still remain 3, right? So what do you do at this point? How can we reduce? Something is common to row 2 that we can use to reduce them.
Multiply by 2.
Row 2 will be what?
2 times
2 multiplied 2 divided by 11 multiplied by row 2. Do you agree?
Yeah, 11 over 2.
Yes. 1, 3 over 2, 5 over 2, 0. This returns to 1, 1, 0, minus 6, 0, 0, 0. Well, something is also common to, what can we do to row 6? Row 3, rather.
Divide by 1 over. Multiply by 1 over 6.
No, divide by 1 over 6.
I don't understand.
Minus 1 over 6. 1 over
Multiply by
minus
1
1
over
over 6, row 3.
Who is talking?
So we can multiply by 1 over 6 as a 1 over 6 row R. Row 3.
No.
Okay.
Minus 1 over 6, row 3.
Minus what? Let me just write it down.
Minus 1 over 6, row 3.
Row 3?
Yes, sir.
Okay. Minus
1 over 6, row 3.
Okay. After that, what will happen?
Let's reach there.
Remember, you have to reduce to the barest minimum.
0, 1, 1.
So what next? What next, please?
Row 2 minus row 3.
So row 3 will be what?
Row 3 implies row 2 minus row 3.
Row 3 minus row 2.
Yes, sir.
1, 3 over 2, 5 over 2, 0, 1, 1, 0, 0, and the rest will be 0, 0, 0, 0. So at the end of the day, our equation will be what? let's say X, Y, Z. So we have X plus 3/2Y plus 5/2
Z.
The last one will be Y
plus Z
equals to 0 equals to 0. So guys, over to you guys to find your X, your Y, and your Z. So that is your assignment. So assignment 1 is this. Then assignment 2 is to calculate your V1 and your V2 and V3. Assignment 1 is to complete this. Assignment 2 is to find your V1. Let me write it there. So it's going to be the assignment 2 is going to be when lambda equals to 2 and when lambda equals to 4. So you solve it, then I think that should be enough for you guys. Don't let me bombard. Now, how do you submit? If you want to submit this question for me now, you will start from the beginning. When we started this particular question, you know you have solution for them, write it there. Please put your matric number. It is critical. Is that okay? Put your matric number. Solve when you have when lambda equals to 4 and when lambda equals to 2. Solve everything, complete question, and scan it to me.
Okay, sir.
Any question?
Yes, sir. So I have a question.
Go ahead.
Sir, for this particular question, I want to know, when you are reducing this, does it mean that the last row should all be 0? Because I've been observing that.
Yeah, that is your target, because you have to reduce it so that by the time the X and Y you will be looking for will be minimal.
Okay.
That is the idea. So our X and Y we are looking for will be reduced. It will not be that you continue to be, you will now have 3 by 3 again. So what is the essence of row reduction? If possible, let row 2 and row 3 be 0.
Okay,
just
sir.
to make your work easy. That's just it.
Okay, sir.
Sarah.
Please, can you share your screen again so that we can copy the assignment?
Oh, there's nothing in the assignment. You've already is in your notes. It's the same thing. You just put when lambda equals to 2, solve it the way we solve it. Complete the one we stop. Do the when lambda equals to 2 and when lambda equals to 4. That's all. You already have it in the quadratic equation you did for lambda's cube. If you still want me to share the screen, I can give it to you.
Please.
Can you see the screen now? Excuse me. Any question?
Yes, sir.
Okay, go ahead, sir.
Yes, I want to relate this the last matrix that we are having here with what we did concerning the pivot that we did last week. Now, I want to assume, let's assume that these ones are the pivot. How can we use this pivot to get our rank?
Now, remember, the one of pivots is a different thing. Majority of the pivots don't have, they don't have the same, they are not square matrices. Do you agree?
Okay, sir.
Hello?
Yes, sir, I'm listening, sir.
So if you want to calculate, it depends. We have, how many methods we have to get our matrix, our rank? Hello, sir.
We there's the one we use the pivot, there's one we use the determinant.
No. What we are saying, okay, what is the rank of a matrix? Answer my question, sir. So you don't know the definition of what you want to solve? Oh my God. It's in your notes. I taught you. And the same note I'm still using. The rank of a matrix is what? Don't let me show you. It's in your notes. We are talking about non-zero row. Remember, I mentioned it. When you are having non-zero element, that's when you are talking about the rank. Check your note, please. Or go and watch the video on the rank of a matrix. It's there. I don't want to bother you. See, only row operation are allowed here. And I explain everything to you about it. Look at it. I intentionally look at it. Non-zero rows. It's very simple. How many non-zero rows do you have at the end of the day? Is the rank of that matrix after your reduction. Do you agree now?
Trying to catch up.
Hello, sir.
I'm listening, sir. I'm trying to.
You don't need to listen. I've already explained.
So for this one, the rank is 2.
If you want to look at this now, what is the rank of this is 2, right?
Yes,
now,
sir.
Because the row here, row 1 is contain non-zero element, row 2 also contain non-zero element. Others, they are zeros. So they are not part of the rank. Now, let's look at this. They can ask you to find the rank of anything. So what is the rank of this one now?
1.
It's 2. Okay.
1.
Oh,
Your
whole. What is the rank of this? I just show you now.
2.
No, you say non-zero, and this non-zero here is 1. Yes.
Non-zero is 1. Correct.
It's
okay.
1.
Who again?
Side 2.
Is 2. Correct. Who again? Anyway, the non-zero here, what do we mean by non-zero rows? If, for example, look at row 2 here. On this row 2, let's say you only have one element here, others are 0, it's still non-zero row.
Yes.
No matter the number of 0 that is there. So far you have one element there that is not 0, they call it non-zero row. That is not 0 row. That is the non-zero row. Is that okay? So how many non-zero row do we have now?
It's 2.
So what is the rank?
It's 2.
That's
okay.
I hope it is clear now.
Yes, sir. It's okay.
I can stop sharing.
Okay.
Our time, is fast spent. I spent almost 1.5 hours after. So